Hi everyone, I'm Josemary on behalf of GemScript, and today we are interviewing iGEM DeNovo Castrians. So iGEM DeNovo Castrians, can you tell us more about your iGEM 2022 project?
Yeah, sure. So DeNovo Castrians this year, we're working on the degradation of BTECs. So that's benzene, toluene, ethylbenzene, and xylene, basically the harmful parts of oil spills in the environment. And we're doing that with organisms. So we've gone and found some naturally degrading organisms in the environment. So they've made the pathways for degradation themselves just naturally. And we're taking those and basically kind of enhancing them and figuring out how they work and putting it into E. coli as our chassis organism. So then we can basically make a better and a possible method of easy bioremediation.
Can you tell us more about how you are modifying the organism to be able to decontaminate the soil?
Can someone smarter than me answer this one?
So at the moment we've got a couple different organisms that can degrade BTECs, and we are going to just have a look at how each of the different enzymes in the pathway function and see which ones are the most efficient and which combinations of those enzymes are the most efficient. And then we're going to combine the most efficient ones into a completely more efficient pathway. And then probably in the long term, put that into a native organism. But for now, it's just E. coli because it's easier to study.
Are there any roadblocks as far as isolating the most efficient enzyme or degradation process that your team has encountered?
Not yet. At the moment, we've mostly just got our enzymes cloned into E. coli, and we're about to start the part of figuring out which are the most efficient. So hopefully no roadblocks, but probably roadblocks.
Oh, I think there has been one, hasn't there? It's one of our degradation pathways that hasn't been kind of seen before. So we don't have really any information on how it works at all. So you have to figure that out.
So it seems like there's a lot of novel investigative processes that have to go on in order to kind of pinpoint the key enzymes that might be involved in the process. So what inspired your team to tackle bioremediation?
One of the Argonauts might want to take that question because I kind of just jumped on once we had a topic picked.
Yeah, I can shortly talk about this. I'm one of the PhD supervisors for the team. So we are from Newcastle in Australia, and Newcastle is a big industrial harbor. There is a big industrial harbor in Newcastle and the surrounding areas. So there is a lot of BTEX contamination within our environment. So that was kind of one of the first steps we had. That is a local issue we have here in where we're from in Newcastle. So that's why we decided to go for that topic to begin, definitely.
I think you just cut out a bit, Joe.
Did you guys hear me? Sorry, I'm on the train in the national park, so connection is a bit dodgy. But we are from the Newcastle has this big industrial harbor here in Australia, and there's a lot of BTEX contamination in our environment and local community. So that's one of the big points that we want to solve, this local issue we have here where we are from, basically.
And I suppose on top of that, the current methods of remediation of these sites isn't optimal. So for example, if you have a spill, more often than not, you have to basically dig that up, take that offsite for offsite chemical treatment. We were hoping that maybe we could optimize the efficiency of that by producing something that can actually degrade these BTECs on site, so you don't have to go through the rigmarole of all that extra effort of digging everything up, taking it off, and doing off-site remediation that way. If we can figure out a way to actually do it on site, that would solve a lot of problems and make things a lot easier.
So it seems like this project would have a lot of tremendous ecological impacts on multiple aspects, both in industry and normal remediation processes. Is your team taking any human practices initiatives to educate the public on the level of impact that this project would have, or how this alternative could be better for the environment, the economy, the industry?
We recently presented to the ARC Center of Excellence. We did one iGEM presentation, I think, and just social media as well, but could probably make a few more posts on
that. Also, the team are starting up a podcast series where they're gonna interview, not like have an episode of what impact this project will have in our local community, but also overall. But they've also give a episode to some of the sponsors we have that's also working within this area as well, and just interviewing other iGEM teams of their projects. But there are definitely other ideas that we are working on and we are getting into doing within the next month or so, starting up on definitely to do the human practices part of the project.
And we also have a radio interview that's been lined up for a while now with a local radio station in Newcastle.
And is there anything unique about the approach of your project that hasn't been done before, or that you would really like our audience to know?
We've got one of the organisms that we're working with, and it's completely novel. And when you have a look at its genome, its BTEX degrading pathway is something that's completely novel and has never been seen before. So we're really hoping to figure out more a bit about it and its pathway and how it works all together. So that's pretty cool.
Yeah, on the novel aspect as well, nobody's been, like, some people have found organisms that can degrade, but nobody's ever made it into something that can be a practical bioremediation tool.
Do you think that this tool could be extended for other applications as well in other industries?
Yeah, I think so. I think the idea of finding the most efficient enzymes in a pathway and then putting them together and putting them into a native organism to help complete different tasks, I suppose, would work. And that could be really interesting and good to apply in other areas.
So the principle of being able to find an enzymatic production or degradation pathway is being used in other areas. Even in my field of research, I'm sort of producing something as opposed to breaking something down, that we are still trying to use the tools or the enzymes in this pathway and then put it in something else to make it, to develop a tool that's better for degradation or production. So it is being seen in other industries, and there's a lot of potential across different sciences for this to be really useful.
I suppose one of the aspects of our project is the incorporation of a biosensor, right? So a biosensor that can detect both the degradation substrate, right, the BTEX, and then also one of the products of degradation, so we can test for efficiency. And then if we can get that working, then that can be applied to any similar situation. I think that would be really useful and really interesting for people who are interested in this kind of thing.
Well, thank you, iGEM DeNovo Castrians, for meeting with me today to tell us more about your iGEM project. On behalf of GenScript, best of luck in the rest of our sponsorship competition and best of luck in the iGEM Jamboree.
Thank you.
Thank you. Thanks for having us.
Thank you so much.